So the GeoGebra illustrations that you guys hung up in the Dropbox yesterday were fabulous. So let's take a closer look at the isosceles triangle. And let's talk about some of the properties of the isosceles triangle in this video. Let's go to properties and let's make this heading a different color. And let's make the text larger. And let's make an isosceles triangle. So I want an isosceles triangle that is not equilateral. So I'm going to ask for an angle that has a measure of kind of like the 72 that makes the pentagon, but let's use another randomly chosen number. So how about a 37-degree angle of the given size. So what are my directions? Select a leg point, then a vertex, then enter the size. Here's my leg point, here's my vertex, 37. Now I have to decide whether I want it to go clockwise or counterclockwise. So do I want it clockwise or counterclockwise? I really want my other point to land over here. So I need my angle to go this way. I'm going to say counterclockwise in this case and see if that works. Yeah, that's what I wanted. So I now need to run segments between these points. So A connects to B and B connects to A prime. It's called A prime because it's a reflection of A. And A was reflected over this line that doesn't appear yet. So let's put the perpendicular line through B through A. And let me see if I can drag one of these points around to straighten this triangle out. And let's make it a little larger. So I asked for a perpendicular line through B that runs through A prime, the segment A prime. Now I'm not wild about the name A prime, so I'm just going to make that C. So let's rename that point C. We're aware that it was made by reflection. I'm going to try to illustrate where the line of reflection was. I want to move this A over here and this C over here. So the interesting thing about an isosceles triangle is that the line that runs perpendicular through B to the base, I'm going to make a point at that intersection. So see how the perpendicular line is highlighted, and I'm now scrolling down so that AC is also highlighted. That means I have an intersection. So I'm putting that point there. I'm putting point D there. And I want you to see the interesting thing about that perpendicular line. That perpendicular line also bisects AC, and we can show that by asking for a midpoint of section AC. When I click this direction, I should get a midpoint that lands right on D. And there it is. I now have D and E right on top of each other. They're the same point, D and E. No matter how I change this isosceles, the perpendicular bisector that runs through B down to this base is also overlaps the midpoint. So that's what allows us to use reflection to say that the angle given at vertex A has to be the same as the angle given at vertex C. So let's illustrate that using the reflection tool. I want to reflect that polygon over this line. And let's change the color of one side just for the fun of it. Object properties, color, let's do neon green. And I want to do one more thing. I would like to turn off this perpendicular line that has no endpoints. So I'm going to turn off the object. And I would like a segment that runs from B to B prime or D. It's got both names in this case. And I'm going to go to the properties of that segment and let's make it a dotted line. That was in style. Drop down arrow gives us lots of choices. And we can change the thickness of it. And we can change the color of it. And it looks like I've changed the color of the whole outside of the polygon. What I really want to do is change segment D to B. So segment A1 it's called. So I'm going to go directly to segment A1 and choose it. I'm going to go to object properties for A1, I think. A1, make it red, dot the line, and make it thicker. Did it work? Yes, there we go. That's what I'm looking for. So I don't want a new point. I just want to unhighlight that center point. So isosceles triangles tend to be marked with a decoration that is found here. We liked the triple one today, so I'm going to use that again. Don't use the arrows because the arrows indicate parallelness, not congruence. And I'm going to mark this one with triple lines to show that it has the same length. Object properties. No decoration there. So I want the segment I'm going to have to find the segment that goes from A to B prime. What do they call that segment? Because I'm getting the whole polygon right now and I don't want the whole polygon. So it's segment D1. So let's choose that. Let's go to the properties of that and let's go to decoration. Here we go. It was the triple mark. Now, the triple mark kind of landed right on the x-axis. So I'm just going to stretch the figure and change the orientation so we can see it just a little better. Okay, so here's an isosceles with a 37-degree vertex angle. I wonder what the base angles are. So the first thing I'd like you to do in tonight's homework, well, I guess it doesn't have to be the first thing. In any order, I would like you to post to the discussion board your answer to this question. What is the measure of the base angle? So I'm going to clarify this question a little bit. I wonder what the degree measure of the congruent base angles is. So let's see. I would like to mark the angles. I wonder if it'll let me put a decoration on the angle. Because I'm really just at a point here. Well, I'll work on that with you work on a solution to the measure of angle CAB and a measure of angle ACB, and post your solution and your explanation to the discussion board called Base Angles of an Isosceles Triangle.